A is a positive integer. For example, what do you call positive integer? What do you guys call this? A. So what number you give? 2, okay. And then B is a negative integer. You call that? Okay, as you wish. Which of the following must be positive? Okay, circle the question. Must means always, right? Always. Always positive. Okay, let's try A. A minus B. A is 2 minus B. Minus negative 3. That 2 minus makes positive is equal to 5. So far, it's okay. A plus B. When you add A and B, it's going to be negative 1. It's gone. A times B, 2 times negative 3 is equal to negative 6. We're looking for the positive one. It's gone. A over B, 2 over negative 3. Result is negative, right? Negative 2/3. A squared. A is 2. 2 squared is equal to? B is equal to negative 3. Negative 12. It's gone. Answer is A. Okay, what is M gonna be? So what is P gonna be? Okay, so let's try. Circle the question. Must be negative in this case. Always negative. M minus P is equal to 1. So this is positive. It's gone. P minus M. 1 minus 2 is equal to negative 1. It's okay. M plus P, 2 plus 1 is equal to 3. It's not negative. Negative, open parentheses, M is 2 minus that minus P. What is P? 1. That makes 2 minus 1 is equal to 1. Negative 1 stays. Negative M plus P, 2 plus 1 is equal to 3. Negative 3. We have 3 choices, but it's saying that all musts. Always. So I should switch them because M is greater than P. Now I'm going to make P is greater than M and then see what's going to happen. Make this one, in this case, 2 and 3, okay? Because why I change kind of like superiority, like 2 was greater than 1. Now I'm going to change. Now P is greater than M because you subtract and add. That'll affect. Okay? And A and C gone. Let's check P. P minus M. 3 minus 2 is equal to 1. So it's gone. Make sense? And then try D. Minus M is sorry. All right, let's try to solve this question without given values. All right, remember what Karen said in the previous question. Circle the question. Must be positive. Must be positive. So since they are negative, guys, you guys paying attention? Since both are negative, when you look inside, if this is negative here, if this is negative, when you add 2 negative number, it's going to be still negative, right? Negative times negative. Okay. X is any positive integers. X is any positive integer. Which of the following terms could be added to some of that? So the new number will be divisible by 7. Okay. So we're going to, once we add them all, what we're going to get? Yeah, that's our goal. When I add them all, 5, 9, 15x. Okay, the question is telling me that 15x plus which one going to be multiple of 7? All right, not confuse you. Okay, multiple of 7, all right? Okay, 15x plus 3x equal 18. x. It's not multiple of 7. Okay, 15x plus 4x, 19x. It's not going to be multiple of 7. 15x plus 5x is equal to 20x is not multiple of 7. 15x plus 6x is equal to, there you go, 21x. So 21x is divisible by 7. So x could be any number. X is, what's that saying? X is positive integer. Let's say 2. Okay, 42 divided by 7 is equal to 6. That works. X equal 1. 21 times 1 equal 21. 21 divided by 7 is equal to 3. So it's divisible. It's gone. That means it's P times Q. The result is negative. And which expression must be positive? Always positive. Okay. PQ is negative. That means there's only one case. So these are not going to work. Am I right? Exactly. They're supposed to be opposite signs. So for example, let's clean these. Either positive or negative. Or this. Okay? Now, wanna just call any number or just plug it in? For example, we can call this one plus 1, negative 1. Okay, P is, what is that? P is negative 1, you said? And Q is positive? Okay, let's solve that then. Okay, A, we're trying A. P square and Q square. Okay, look at this. If you're taking a square of any number, the result is going, Caleb, the result going to be positive or negative? Taking a square of anything, going to be positive, right? For example, negative 2 square is equal to positive 4. Positive 2 square is equal to positive 4. Let me write it down. Any number square, for example, negative 1 square or is equal positive 1 square, because this is positive 1. So why I'm explaining this, because there is P square and Q square. The result anyway going to be positive. Is that clear? So negative 3 times some positive number, let's say any number, it doesn't matter, result is going to be negative. Okay, P times Q, it's given. P times Q is negative. Okay? So negative times negative. Is that clear? Negative 4 times PQ. Anything negative going to be positive. Oh, is that the answer? And P plus Q squared. I have no idea what is P. It could be positive, it could be negative, alright? But I'm pretty sure Q, exactly. I'm sure this is positive. But P, it depends. If it's positive, result will be positive. If it's negative, it could be negative, it could be positive. If it's bigger than Q squared, it's going to be negative. It's less than Q squared, it's going to be positive. It depends. Does that make sense? Let's say P is positive 1, alright? Q is negative, let's say negative 2, I'm just making up. Negative 2 squared equals still positive. That makes positive in this case. But let's say P is negative 7. That's possible, because if this is negative 7, this is something positive. Negative times positive equals negative, that works. And then Q is 1. Q squared equals 1 squared, that makes positive 1. The result will be, in this case, negative 6. Not always positive. It could, but this is important. Must. Done. And then P times Q squared. Okay, let's say P is negative, Q is positive, alright? Negative times Q squared, Q is positive, times positive is equal to negative. Once you look at this, let's say Q is positive. Q is positive, P is negative. If q is positive, this is negative 2 plus, if I call p is 1, 1 squared is equal to 1, it's going to be negative 1. So I disprove that.
Yeah.
So m and m
right now.
times x, so the result is negative integer.
Yeah.
So m and x supposed to be opposite signs. If this one is positive, x supposed to be negative. If x is positive, m supposed to be negative. Must be true. Okay, let's see. Negative m minus x is negative integer. It depends. Yeah, it depends on the amount. We be not always, because it depends which one has more. All right. So let's say, should I give example? It depends. Let me just make clear for everyone. Let's say this is positive 7 and this is negative 1. Okay. Let me check. Negative m minus x, negative times negative positive, that makes negative 6. Okay, and it's saying that is a negative integer. But if you switch and try these, negative 7 and positive 1, let's switch the quantity, because negative times positive still works. When I apply that, it's not gonna work. Let's see. Negative m is 7 now, right? Negative times negative positive, minus x is 1. X is 1. That makes 7 minus 1 is equal to 6. In this case, it's positive. So it's saying must, it's gone. M minus x. Let's check this one. 7. Yeah, remember that. This is not even an option, so we don't need to even try that. Okay, it's gone. Right, see? None of them has 2.
But the one is already wrong. If one's wrong, everything's wrong.
So 1 is wrong, and then delete this one, right?
And B, and C, and D.
And B. Oh, so bad. This is so sad, because we eliminate 1, we solve the question. We don't need to even check these. Okay. So answer is D. So what x supposed to be? Positive times positive will be positive. If k is positive, I have to use the same thing, k positive. So y is supposed to be, and then what is that? Y. Y is positive. Taken away. Cesar? What? Okay, get back to the question. X. So what is y? Is y is positive here or negative here? Has to be positive. Okay, if y is positive, x supposed to be positive. And another alternative, another choice, another case, I have chosen k positive here, and then I'm gonna pick negative for k. If k is negative, x supposed to be y, because negative times negative is equal to positive. So k is positive or negative here? Can be positive. Why? Because I put here is negative. It has to be same.
Yeah, but then the y part
But
should be positive.
we don't know that yet.
That's kind of
If the question is not specifically telling y is positive, products are positive. I know ky is positive, but I choose k is negative here. I must choose k negative here. So if k is negative, y is supposed to be negative. Okay, y is negative. X supposed to be negative. In order to result supposed to pass. Okay, let's Check the answer choices. K, okay. Underline this. Underline this. Must be true. 1, K, X, and Y are positive. See? Not always. See the choices? Sometimes it's positive, sometimes it's negative, but this is telling me always, not sometimes. It's gone. Oops. Change. Cross it out. Okay, only 2 of the integers are negative.
So all three of them.
Yes, all 3 of them have to be positive. All 3 of them they have to be negative. So it's saying only 2. This is not correct. K, X, and Y are negative. In this case, this is correct, but not here. So result is only
They're all
4. Make sense? Now it makes sense once you put the possibilities at first, you see everything more clear. Either positive or negative. What do you call n? N is negative 1?
Yeah.
Okay, let's try. N is negative integer. 1 over n is negative 1 minus n squared. Negative 1 squared equal positive 1. That makes negative 1 minus 1 is equal to 0. See, there's only one. So I made a mistake. It's just one correction came. Okay, negative 1 minus 1 is equal to negative 2. So what is the question? Circle the question. How many values of n?
It's the only one. You have to make it if you put any other value, it will be a fraction.
Yes, yes. Okay, well, let's try negative 1. Let's try negative 2. When you plug in negative 2, is that going to work?
No.
1 over negative 2 plus something. It's going to be fraction. So increase the number. 1 over negative 3, 1 over negative 4. It's going to make that decimal. So there's only one. Okay, the sum of 3 unequal. Also they're unequal and positive is 35. I want to be I need to focus on the smallest integer. We're going to make operation over here. So what is the largest possible value of the smallest? So largest possibility, so which is largest numbers is 12. So in order to make sure, I'll start from there. Let's say it's 12. If it is smaller, this one's supposed to be bigger, like 13. Let me check the details. Unequal positive integers. Okay, 13 is not equal to 12, and then the next one going to be this.
No, it doesn't work.
Let's add. It's going to be 39. Correct? It's exceeded. So that this is too much. It's saying largest. Okay, larger, but too much. Okay, change. Try 11.
It won't work because 35 minus 2.
Right, when you add it up, it's going to be already 22, 23, 33 plus 3. It's exceeded, right? That makes 36. 36. This one was what? Let me clean up. 39. It was 39. My goal is still same. I'm trying to get this number. It's still too much. 10 plus 11 plus, let's try this. It's going to be 33, too small. That's fine. I can increase because there's no limit here.
It's 10, 11, 14. 10, 12.
That works because 10, 11, that makes 21, 31, 31 plus 4, 35.
You can find those numbers by subtracting them.
I can make this. Wait a second, we're trying to find 35, right?
Yes.
Not 36.
12, 13.
Yeah, it's up to you guys. You can just, after you get the right number, smallest. So this is the largest possibility. 11 didn't work, slightly exceeds. 11 slightly exceeds, so once you write here 10, then you can arrange, you can make it 10, 11, and 14. That works. Okay. What else works? 10, 12, 13, 10, 13 gonna work? No, it's not gonna work, right? Because it's gonna exceed. So we have two different possibilities. That could be another question though.